Hi everyone, today we have a normal distribution into a binomial distribution paper 2 style question. Now I phrased it like that because it's immediately clear that it's a normal distribution, but later in the question it turns into a binomial distribution, and part of the hard bits about this question is that you need to recognize that. So I will explain as we go. The company Fred Express delivers packages. From past experience, the time taken T to deliver a package follows a normal distribution with a mean of 64 hours and a standard deviation of 12 hours. So from the question, it's immediately clear it's a normal distribution. Part A states the probability that T is less than 64. So let's go stat mode on the calculator. Let's go distribution, normal, and we want NCD because it is cumulative. We need to state, let's do it up here, A, the probability that T is less than 64 equals, so my lower is going to be 0, my upper is going to be 64. This one here is the standard deviation of 12 and the mean of 64. Press equals and we get 0.499, which equals 0.5. That is for part A. For B, we want the probability that T is between 44 and 64. So 44 is less than T, which is less than 64. So same deal, but let's change the lower bound to 44. The upper is going to be 64. Press equals, and we get 0.452. 452. Okay, 30% of packages are delivered in less than K hours. Sketch a diagram of this normal distribution, shading the region that represents the probability that T is less than K. So you need to do this as neat as possible. Let's start with just a straight line at the bottom here. Whoop, let's try and get that actually straight. Okay, it's not exactly straight, but you get the idea. You need, as best you can, a normal distribution. So a normal distribution looks something kind of similar to this. You want to try and make it as neat as possible. You need the mean, which is going to be straight up and down here. You need this value to be 64. Why? Because it says in the question, right at the top, it says we have a mean of 64, so that needs to be 64. And back to question CI, it says 30% of packages are delivered in less than K hours. So K is going to be kind of down here somewhere. So let's call that K. And you also need to shade the region. So all of that region that is less than K, I need to shade that in. Now, yours needs to be hopefully a little bit neater than that, but you get the idea. K has to be less than the mean, and we have satisfied that question. CII, find the value of K. So now we need to go back to stat mode, distribution, normal distribution, and we want the inverse normal. We want it to be a left tail because you can see from my diagram, it's a left tail. And then if I look at CI again, it says that 30% of packages are delivered in less than K hours. That's why my area here is 0.3. The standard deviation is 12, just like it was. The mean is 64, just like it was. Press equals, and we get K equals 57.7. Okie dokie, next part. For quality control, the manager randomly selects 5 outgoing packages. These selections are independent. Find the probability that exactly 2 of these packages are delivered in less than K hours. Now, this is probably the hardest part of the question, this part in here, because you need to recognize that it now has turned into a binomial distribution style question. How do you know? It says these selections are independent. Independent is a hint. It means that the probability of the first selection has no influence over the probability of the second selection. An example of that is like you're flicking heads or tails on a coin. If you get a heads, then it makes 0 difference the second time you flick it. If you get a heads or a tails, it has no influence. That's independent. So find the probability that exactly 2 of these packages are delivered in less than K hours. So what we have for part D, we have a binomial distribution because you could either, they are delivered in less than K hours or they aren't. So there's 2 outcomes. We have the number is 5 because they're selecting 5. And we've got a probability of 0.3. Why is it 0.3? Because it said back in the question CI that 30% of packages are delivered in less than K hours. So the probability that it is delivered in less than K hours, for the purpose of part D here, is 0.3. Now, we want the probability that exactly 2 of these packages are delivered in less than K hours. So the next part of this is we want that the probability that X equals 2. Again, it says 2 of these packages are delivered in less than K hours. Now to my calculator. Exit back out. Distribution, binomial, BPD, we want X to be 2 from where I just wrote it down. We want the number of trials to be 5 because it says they are selecting 5 outgoing packages. We want the probability to be 0.3. Let's press execute and we get that as a number. So I'll do that over here, 0.3087. 3 significant figures is 0.309. That's the hardest part of this question in my view. Next part, E. Fred Express charges a fixed amount of $4.50 for any package weighing 1 kilogram or less. Heavier packages are charged an additional fee of $2 per kilo. This fee is applied for any weight in excess of 1 kilogram. For example, a 1.5 kilo package is charged an additional $1. For E, it says write down an expression for the amount charged to deliver a package of weight X kilograms, where X is larger than 1. So, the first part of this is the $4.50 fixed fee. So I'm going to start with that. I've got 4.5 plus, it says down here, it says $2 per kilo for anything that's over 1 kilo. So how we can write that is $2 for anything more than 1 kilogram. So the way that we're going to write this is we're going to have X minus 1. We could quickly check. If I have a 1 kilogram package, then X would be 1. 1 minus 1 is 0. 2 times 0 is 0. So for a 1 kilo package, I don't have to pay any extra, which that fits with what the worded scenario is over here. For a 2 kilogram package, X would be 2. So 2 minus 1 is 1. 1 times 2 is 2. 2 plus $4.50 is $6.50. So we would have to pay extra. If you're not sure if you've done it correctly, then maybe on some spare bit of paper, plug in a few or substitute in a few different weights and see if your model makes sense. So I've just done a quick little check to make sure that our model makes sense. That's for part E. That's all we need to do for part E. For F, down here, find the amount Fred Express charges for a 5.3 kilo package. So $4.50 plus 2 outside of X is now going to be 5.3 minus 1. Let's get the calculator. So we've got 5.3 minus 1 is 4.3, times that by 2 is 8.6, plus 4.5 is 13.1 dollars. So we should really say that it's $13.10. If you're dealing with dollars and cents, usually you take it to 2 decimal places. That is for part F. And then for part G, it says mailing is charged $7.20 for the delivery of a package. Find the weight of mailing's package. So for G, we have $4.50 plus 2 outside of X minus 1, and all of that equals $7.20. So all we need to do is rearrange this and get X by itself. So I'm going to do 7.2 minus $4.50. So 2 outside of X minus 1 equals 2.7. Divide that by 2 is 1.35. X minus 1 is 1.35. Add 1 to that to get X by itself. So 2.35. Find the weight of mailing's package. We would need to say that the weight is, or the weight of mailing's package is 2.35 kilograms. Okay, bit of a doozy of a question. We've got a normal distribution for the first few, and then it turns into a binomial distribution. You need to become familiar with part D, because that is the hardest part of this question. And then parts E, F, and G, really that just turns into a linear equations type of question. So lots of marks. You need to show all of your steps. You need to be nice and neat with your diagram, and you need to show the correct terminology. For example, in A, the probability that T is less than 64. Those types of things you need to show for full marks.